Okay, here we go. A derivative is our definition for the day. What is the definition of a derivative? Well, Webster's dictionary says something that is based on another source. So in math terms, if we think of a derivative in terms of x and y, it is the instantaneous rate of change of y, or the output, with respect to x. So as x changes, y changes. As x changes, y changes. What does that sound like something else we've done in math before? As x changes, y changes. Slope, yep. So slope implies derivative. Slope, we would say, is the average rate of change. This word rate, the phrase rate of change, those all imply a derivative. But what we want to really truly focus on for the derivative in this class is that a derivative is going to be the instantaneous rate of change at a given point. So that means the tangent line, not the secant line. And so we are now ready to give, the derivative of function can be denoted by an operation. Now, my son is in third grade and he's learning operations, addition, subtraction, multiplication, division, and he's wondering what other operations he'll encounter someday. So what should I share with him? What other operations may he see someday? Yep, log, square root, something squared, absolute value. What else we got? Natural log, sine of something. How about this? How about an inverse operation on a function? Did we learn that last year? Did you learn how to compose functions last year? So all of a sudden you're like, wow, we've got a lot of different operations that we're focusing on. Here's the operation you're learning today. If you see, very good. I thought we made the joke last year. All right, so if you see this little tick mark right here, right after the F, it's like an apostrophe, that means derivative. We say F prime, okay? And that means derivative. So here's the notation that we use. The derivative of a function at point A is equal to this, okay? So, meaning we get to write f prime as opposed to writing out all of this stuff, okay? So this is shorthand for this. The limit as h goes to 0 of f of a plus h minus f of a all over h. Now, you know what that is because we did that yesterday, right? You found that instantaneous rate of change at a given point. You did the algebra of this section. Today we're going to talk a little bit more about the conceptual pieces and talk about the language of what's going on. Example 1 says, let's look at the function to the right. This is f of x. And what I'd like to do is I'd like to be able to arrange these values in increasing order. So I'd like to start with the smallest value. I'd like to go with the biggest value. Okay, so we're going to estimate what f prime of negative 4 is. That means I find the function value at negative 4, which is approximately right there. But right now what I've shown is f of 4. That's f of 4. If you want to look at f prime of 4, you're looking at the slope at that point. So if you were to describe that slope, how would you describe it? Yeah, in fact, I would say really negative. F prime of negative 3. I locate f of negative 3 as I draw a line tangent there. What would you estimate to be the slope of that tangent line? 0. So we say that f prime of negative 3 is 0. We're performing an operation. Just like addition or subtraction, we're performing an operation. F prime of negative 1, how would you describe that? It is positive. How about f prime of positive 1? It's negative. How about f prime of 3? So you may not like those descriptive words, but they help us put it in order of smallest to largest. Go get some brain food, come back smarter. You know what I'm glad about? None of them have asked for letters of recommendation yet. So, like, I hope they do. I hope they do. Rejection letter, rejection letter, rejection letter. All right, here we go. All right, so now we have all these values. I'm going to arrange them in order from least to greatest. So which one of these is the smallest? F prime of negative 4 is the smallest. What's next? F prime of 1. So that's, we say prime. Prime means the derivative at that spot, which is less than F prime of negative 3. Not F of prime, F prime. It's okay. You're smart. We all know it. F prime of negative 1 less than F prime of 3, right? We're all good? Okay. Flip it over. And I know that this graph isn't the best, but you try this one on your own. Try to order them. If you can't tell which one has a steeper slope, just make an educated guess. I promise on the test will be distinctive. Also on the AP exam, anytime I've seen these type of problems, they are very distinctive in regard to the slope, so don't worry too much about it. Okay, I said that F prime of negative 7 was more negative than F prime of negative 2. So I understand if you maybe mixed up these two, but the rest of them really should be in this order. We got negative, or 7, negative 2, 0, negative 5, 2, and negative 4. You can see that if I thought it was really positive, I'd put 2 positive signs, just kind of give myself an indication. How's that? Is that okay? You all good with that? Okay. So anytime you're asked about a derivative, you're looking at the slope. So you're making these kind of tangent lines all over the place. All right, let's flip it over. We're going to get back to that one tomorrow. Okay. Got some other work to do tomorrow. But, today, it says we're going to end with this example, example 4. It's to sketch a graph of a function that satisfies the following. Okay. So we have some conditions that we want to meet here. What does that mean? Good. At 0, the y value is 4. That means it passes through the coordinate. No. We'll get to that. So right now, the condition that we have been told is that this function passes through 0, 4. That's what that means. Now, the second condition says that f prime of 0 is 1. Okay? I'm going to leave that one aside and get to that later. This one says f prime of 2 is negative 3. I'm going to get to that later. But I'm going to look at this one. It says f of 1 is 0. What does that mean? Good. So what do those prime things mean then? Yeah, at 0, I have a slope of 1. So I'm just going to make a little sketch, just a little line that goes through this point 0, 4 that has a slope of approximately 1. You okay with that? So right now, this function has a slope of 1 right there. It passed through 0, 4, and it passed through 0, 1. F prime of 2 is equal to negative 3. Do I know what the y value is at that spot? I don't. I just know the slope, right? So I got to have a slope that's negative. It looks like before that I'm here at 1, 0, so I'm going to I'm just going to draw a slope of about -3 somewhere around there. So now I'll finish by drawing my function that meets these conditions. Okay? That was kind of bad. Probably shouldn't go straight up and down. Okay? So as you look back at our conditions, it goes through 0, 4. It goes through 0, 1. At 1, it has a slope of 0. Or at 1, it has an output of 0. And at 2, it has a slope of -3. Now, this is important. Notice the directions. It says sketch a graph as opposed to sketch the graph. What is that? What is the difference between saying sketch a graph and sketch the graph? Yeah, there's more choices. A is what we refer to as an indefinite article. The is a definite article. In English, for those of you guys studying language, I'm going to do another one, okay? Just to show you the multiple opportunities that we have. F of 0 is 4, and it has a slope of 1, we said. How do you like me now? Still satisfies those conditions, right? I like that. You try the next one on your own. I don't care what kind of graph you make. You can make a piecewise function. Doesn't say it has to be continuous. Okay, see if you can do the next one. What? No, we had a coaches meeting this morning. All coaches. All coaches. We do it every month. No, I'm licensed for 5th through 12th grade. I'm licensed to teach not by subject, but by grade. The reason anybody here can teach calculus. The reason why I have to do it here is because I'm the only one with 18 graduate credits in mathematics, which gets you guys your credit. But anybody else can teach calculus. Okay. Okay, raise your hand if it looks something like that. Okay? There you go. You got an open circle here? So you went like that? Okay, so it went like this. Okay, all right. Everybody pause. This is where we could get in trouble. I'm glad you did this. This is a really good point. In order for it to be differentiable, in order to have a derivative, it has to be the same slope on the right-hand side as it does on the left-hand side. So you can't have just an open circle and then go. It has to pass through. Now, if you would change that, so I'll show you. I'll show you another option here. Okay. Suppose you did this. Suppose you had your point there and your point here. Okay. Let's say you did this. You had a slope of open circle. I passed through that point, right? Both on the right and the left. Then we can count the slope as that. But you can't have it right at that spot. And then maybe over here, maybe, well, yeah. So then we say, okay, now we're going to do slope of -2. So we have a slope of -2 and a slope of 1/2 now. But you can't put it right at that spot. So it says f prime of 1 is 1f. It's got to go through the left and the right. We cover that tomorrow. Very short assignment, folks. Very short. We're going to pick up the rest tomorrow. Here you go. Just problems 3, 5, and 6. You're going to add to that assignment tomorrow. Add to the assignment tomorrow.